Hello students. So previous class we already discussed about friction, and today we are going to discuss about a new topic in your physics syllabus, that is work, power and energy. Work, energy and power. Okay. So in our day-to-day life you all use these words frequently. Okay, you all know what is work. So in the language of a layman, work is something that we are doing. For example, I am writing here something. So I am writing. So the writing is the work I am doing right now. Okay, so writing is a work. So anything that we are doing is known as work. What is energy? So energy means it is the ability to do work. That means, for example, if I am writing, so writing is the work. But how much I can write? For example, in an hour I can write this to this much. Then this is the energy of mind to write something, because I can write this much length or this much width of a stanza at a time, or in a given time interval I can write this much length of passage. So the amount of doing work or the ability to do work is known as energy. So my energy is that I can write this much. Clear? Then what is power? So power means how fast you can do something. That means how fast I can write. For example, in 1 hour I can write 1000 words. Or there is someone else who can write in 5 minutes 1000 words. So the speed or rate of writing something is maximum in this case, because in 5 minutes he can able to write 1000 words and I am able to write 1000 words in 1 hour. So the power is maximum in second case in comparison to the first case. Clear? So work is something that we are doing. Then the amount of work done by someone is depend upon the energy of that person. Then power defines the rate of doing work, how fast someone can perform a work, that is known as power. So in this chapter we are going to discuss about work, energy and power separately. Clear? So first of all, let's discuss what is work. In day-to-day life, the term work we used is very different in comparison to the word or term work in case of physics. Okay, so what is work by physics? So work can be defined as, in the language of physics, that it is the dot product of applied force and the displacement happened due to that applied force. When we apply force on something, any push or pull we know is a force. So if we apply force on any object, it may get displaced or not. So if that object get displaced by that applied force, then the amount of work done will be equal to the magnitude of that applied force with the displacement occurred due to that applied force. For example, if here is a block have mass m, okay, and I am applying a force along this direction F, which makes an angle theta with respect to the horizontal. Clear? So it's at rest on the surface here at t equal to 0, x equal to 0. So at t equal to 0 the body is at origin or at rest, and its velocity also equal to 0. So after certain time, due to the applied force, the block moves to this point at t equal to t second. Let x equal to x. Clear? And it occupies some velocity v. So this displacement of the block, it has mass m, is known as x, because due to application of this force it displaced from this point to this point. So the force has two components. One component is along the direction of displacement. This is the component of the force, which can be given as F cos theta, and this is the component which is perpendicular to it, that is known as F sin theta. Clear? So what is work done by displacing this block from this point to this point? So the work done W can be defined as F vector dot the displacement vector here can be written as x vector, or this can be written as F vector mod x vector mod cos theta. Clear? Because we know the dot product of two vector quantity is the product of magnitude of both the vectors and the cosine of angle between both the vectors. So here this is the direction of displacement and this is the direction of applied force, and this is the angle theta between the direction of displacement and applied force. So work done will be equal to how much? F mod x mod cos theta. Okay. So or else we can write this as, from this equation we can given that F cos theta. From here we can write F vector mod cos theta equal to what? Component of applied force along displacement. So work done can be defined as the dot product of applied force and displacement, or also it can be defined as the product of the component of applied force along the direction of displacement and that of the magnitude of displacement. Clear? So from this we can write the work done by an applied force can be defined as work done by an applied force, let F vector, can be defined as the dot product of applied force and displacement produced due to the applied force. So from here we can write work done equal to F vector dot S vector. Clear? So this is one statement or the definition of work done. It is defined as what? The product of dot product of applied force and displacement produced due to the applied force, F dot S, because here let this is the displacement S from this point to this point and this is the applied force. So F dot S will define as the work done. This is one definition. Or else, as we already discussed before, how work done can be defined as the product of component of applied force along. Work done can be defined as the product of component of applied force along the direction of displacement vector like here W is defined as the product of component of applied force. This is the applied force F and this is the component of applied force along the direction of displacement, and the displacement produced. So F vector mod cos theta into the displacement produced, that is S vector mod. So this is also defined as the work done. So we can define work done as the product of component of applied force along the direction of displacement and the displacement produced, which can be written as like this, or the product of component of displacement and magnitude of applied force okay, or the product of component of displacement along applied force, component of displacement along applied force and magnitude of the applied force. Clear? So as here we are splitting the applied force into two components, one is along the direction of displacement and another one is perpendicular to the direction of displacement, or else here we can do that, we can split the displacement vector into two components, one is along the direction of applied force and other one is perpendicular to it, like this. So as here this is the direction of displacement, so here we can redraw it like this. If this is the direction of applied force F and this is the direction of displacement produced due to the applied force S and the angle between them is theta. So now we can resolve displacement into two components. One is along the direction of applied force, let this is S vector mod cos theta, and the other one is perpendicular to the direction of applied force, that is S vector mod sin theta. So according to this definition, the product of component of displacement along applied force and magnitude of applied force can also define work. So here we also can write W equal to S vector mod cos theta into F vector mod. So this is also the work done that we can define. So work done in physics can be defined in three ways. One is the dot product of applied force and the displacement produced due to that applied force. Next, it is the product of component of applied force and the displacement, and the component must be taken along the direction of displacement, or else it is the product of component of displacement along the direction of applied force and that of magnitude of the applied force. So in these three ways we can define work in physics. Okay, so you have to remember the definitions and the formula. Okay, so here we can define work done can be written as F vector dot S vector, or this can be written as F vector mod S vector mod cos theta. Clear? So you have to remember certain point regarding this. Here S vector is the displacement of the point of application of force. Okay, you have to remember this point. Here S is the displacement of the point of application of force. It is the displacement of that point where we are applying the external force. But you have to remember, in most of the cases, as we are only dealing with rigid bodies, this is the displacement of complete body, because in case of rigid body the point of application has certain displacement, and that displacement is equal to the displacement of each and every particle of the body. But there are certain cases, if we are dealing with certain flexible bodies like this, if this is a body, this is not rigid, this is flexible. So if I am applying a force at this point, so maybe the complete body may not get any displacement, but this point of application may get displaced like this. If this point is here and I am applying force, it get displaced, but the complete body remains stationary. So in this case, the work done will be the amount of applied force and the displacement of this point of application. Okay, as this point get displaced but the complete body remains stationary. So here the work done will be the applied force and the displacement of this point of application. Clear? But in case of this, as this is a rigid body, so if I am applying a force here, it get displaced. So in this case, the displacement will be the displacement of the complete body. But in general, you have to remember S is what? The displacement of the point of application of force. If the body is rigid, then that will be same as for complete body. If the body is flexible, then you have to determine the displacement of that point of application of force. Clear? So you have to remember that in this case, work done equal to F dot S, where S is the displacement of point of application of the body. Clear? Next, as work done is defined as the dot product of two vector quantities, so it is a scalar quantity. So work done is a scalar quantity. Okay, work done is a scalar quantity. Unity in SI system, it has unity joule denoted by capital J. In CGS system, it has arc. Okay, clear? Or joule can be defined as the product of force into displacement. So joule can be written as 1 Newton into 1 meter, because Newton is the unit of force in SI and meter is the unit of displacement in SI. Similarly, in case of CGS, it can be written as 1 dyne into 1 centimeter. Clear? You have to remember the unit of the work in SI system. So these are known as absolute unit. Okay, the other one is gravitational unit. So in case of gravitational unit, displacement has same unit meter in SI and centimeter in CGS, but the Newton will converted into kg force and dyne will converted into gram force. So work done in gravitational system of unit has unit in SI system, that is 1 kg force meter, and in CGS it will be 1 gram force centimeter. Okay, but you have to mainly remember these two, joule and arc. So what is the relation between joule and arc? You have to remember, it can be asked in a 1 mark question. The relation 1 joule will be equal to 10 to the power 7 arc. Okay, you have to remember this relation. Clear? Then next point regarding work, you have to remember that work, what is the dimension of work? The dimensional formula for work is M1 L2 T minus 2. Clear? You have to remember this, M1 L2 T minus 2 is the dimension of work. Next, work done depends upon frame of reference. Okay, it's an important point. You have to remember, work done depends upon frame of reference. Why? As work is defined as F dot S, So we know a individual force is independent of frame of reference, but displacement depends upon frame of reference. So as displacement depends upon frame of reference, so work done depends upon frame of reference. So work done depends upon frame of reference as displacement depends on frame of reference. Okay. So these are certain points regarding work. You have to remember that work is a scalar quantity. It can be defined as the dot product of applied force and displacement produced due to that applied force, and basically displacement represents the displacement of point of application of force, but in most of the cases we are dealing with this as same as that of the displacement of the complete body, because in case of rigid body the displacement of point of application of force is same as that of the displacement of the complete body. Clear? Next, work depends upon frame of reference as displacement depends upon frame of reference, the dimension and unit of work. Clear? So next, work can be positive, negative and zero depending on the angle between applied force F vector and displacement vector, as work done equal to F dot S, or this implies you can write work done W equal to F mod S mod cos theta. So where theta equal to angle between force, applied force and displacement vector. So depending upon this theta, work can be positive, negative and zero. Clear? So when positive work, for positive work theta must be equal to how much? If theta complete work is positive, this is the mod, so cos value, theta value must be positive. So what is the value of theta for positive work done? 0 degree. Okay, or if theta 0, cos value will be 1. So work done will be maximum and positive. So if theta lies between 0 to pi by 2, okay, like this, 0 closed, pi by 2 open. If theta lies between 0 to pi by 2, then the work done will be positive, like this. If this is the direction of displacement and this is the direction of force, okay, here if theta lies between 0 to 90, then the work done will be positive, and for maximum, for positive work theta lies between 0 to pi by 2 and maximum work equal to Fs when theta equal to 0 degree. Okay, when theta will be 0, if this angle will be 0, then the work done will be maximum and positive. So if the theta varies between 0 to 90 open, that means 90 degree is not included, excluded 90. So up to this, like 89 degree, the work done will be positive. Clear? And when the work done will be maximum, when the theta will be along the direction of displacement. Clear? So positive work done when the body displaces along the direction of applied force. So example, when a body accelerates, when a car accelerates, the work done by the engine will be positive because the engine wants to accelerate the car. So the car is displacing along the forward direction and the body will apply force along the direction of displacement. So the work done will be positive. So when displacement and force are along the direction, same direction, then work done will be maximum and positive. Clear? So example, we can write work done by engine during acceleration of a vehicle, of a car, okay, is known as positive work done. Clear? So when the applied force and displacement are along same direction, then the work done is positive and it has maximum value, but the work done remain positive until the angle between applied force and displacement varies from 0 to less than pi by 2. When theta, or we can write when theta is greater than equal to 0 and less than pi by 2, the work done will be what? Positive. Clear? Next, negative work done. So according to this equation, for negative work done, theta is greater than 90. Clear? If theta is greater than 90 and it must greater than 90 and less than theta is greater than 90 and less than equal to 180, then the work done will be negative. For negative work done, theta is greater than 90 and less than equal to 180. Clear? So if the angle between, this is the direction of displacement and the force is applied like this, which is greater than 90 degree and lies between 180 degree, then the work done will be negative because it has two components, one is along this direction and other one is along this direction. Clear? So as the force and the displacement has an angle between them theta which is greater than 90, then the work done will be negative and it is maximum when theta equal to 180. Okay, so the negative work done will be maximum when theta is equal to how much? 180. But the work done will be negative when theta is greater than 90 up to 180 degree. Clear? So when theta varies from 90 to 180, the work done will be negative and the work done will be maximum in negative case, that is when theta equal to 180. So in this case the work done equal to how much? Minus Fs. This is the maximum value of negative work done. Maximum negative work done. Clear? So when theta equal to 180 or the displacement and the applied force are in opposite direction to each other, the work done will be negative and maximum, that is minus Fs. But when theta varies from more than 90 and less than equal to 180, the work done will be negative. Clear? Example, the work done by brake when a vehicle is accelerating. Clear? So when a vehicle is accelerating, the work done by the frictional force due to brakes are negative work done. Clear? So here you can write the example for negative work done, or you can remember that for negative work done when displacement and applied force are in opposite direction. So when a vehicle is accelerating and we are applying the brakes, so the work done by the frictional force produced due to the brakes is negative because displacement is along this direction, body is accelerating along this direction, and due to application of force the body is retarding. That's why the retardation or the acceleration will be along this direction. So the force applied along this direction and displacement occurs along this direction, so angle between these two is 180, so the work done will be negative. So work done by the applied force due to brake when a vehicle is accelerating, it's negative work done. Clear? So you have to remember when the work done is positive and when the work done is negative, and the examples. Next, when we are lifting a box, if I am lifting this box, so the work done by the applied force or the lifting force is positive because the box is displacing upward and I am applying the force due to which the box is displacing upward. So the work done will be positive, but the work done by the gravitational force with which the earth attracts this body is downward, but the body is lifting upward, so the work done by the gravitational force will be negative. So when applied force and displacement are in same direction, the work done will be positive and the maximum value is Fs, and when the applied force and displacement are in opposite direction, the work done will be negative and the maximum value is minus Fs, and you have to give some examples if asked in your examination. Clear? So next, for zero work. So when the work will be 0, so for 0 work, theta equal to 90. So when theta equal to 90, cos 90 will be 0, so work done equal to 0. So for 0 work, the displacement and applied force are perpendicular to each other. Okay, clear? So when displacement and applied force are perpendicular to each other, the work done is said to be 0. So what are the example of 0 work done? In a platform, the pulley keeps some luggage on his head and walking along the platform. So the weight of the luggage is acting downward from his head to the bottom, but the pulley is displacing along the platform horizontally. So if here is a pulley which is walking on the platform carrying some luggage on his head, okay, she is walking along this direction and the weight of this luggage mg acting downward. So the angle between the weight and the displacement of the pulley is 90. So according to physics, the pulley is doing 0 work because the weight of the luggage which is acting vertically downward and the pulley is walking along the horizontal platform. So here the angle between weight mg and displacement s of the pulley is 90. So work done will be 0 according to physics. Clear? Okay, so this is one example. When a pulley walk along the platform by carrying some luggage on his head, the work done by the pulley according to physics is 0. But you have to pay in your real life for that work. Okay. Another, when a body is moving in a circular path like this, if a block is tied and revolving in a circular path of radius r. So in this case, the displacement at any instant of the block is tangentially along this direction, but the force which is responsible for this motion is known as centripetal force. Okay, this is Fc, F centripetal, which is acting along the radius. So at this case, the displacement of the body and the force due to which the body is revolving has an angle between them 90 degree. So here the work done will be 0. So work done by centripetal force. Because the angle between centripetal force and displacement, instantaneous displacement of the body which is executing uniform circular motion is 90 degree. Clear? Another example is when a substance is executing SHM or doing oscillation like this. Okay, so if this pendulum is executing SHM like this, to and fro motion like this, so at any instant the displacement is along this direction, but the tension along the string, if this pendulum is tied with a string, is along this direction. So work done by the tension during oscillation of a pendulum is what? 0, because the tension always acts along the string and the displacement of the pendulum is always tangent to it. So the angle between tension and the displacement is 90 degree. That's why the work done by the tension during the oscillation of a pendulum is 0. So here we can write another example, work done by tension during oscillation of a pendulum is 0. Clear? So work done during the oscillation of a pendulum is 0 because the tension always acts along the string and the displacement at any instant is tangential. That's why the angle between them is 90 degrees, so the work done will be 0. So when theta is 90, the work done will be 0. When theta is 180, the work done is negative and maximum, and when theta is 0 between displacement and applied force, the work done is positive and maximum. Clear? So you have to remember the condition when the work done will be positive, when the work done will be negative, and when the work done will be 0, and you have to remember the examples for your examination purpose. Okay. Okay, so next we are going to discuss what is conservative force and non-conservative force. So what is conservative force? So conservative force are those type of force, the work done by these forces is independent of path followed. Okay, so conservative force, these are the forces work done by which is independent of path followed. Okay, so conservative force are the forces work done by which is independent of path followed. That means work done by this type of force does not depend upon the path. For example, if this is the point A and this is a point B, I am displacing a body from A to B by covering this path by application of an external force F. If this force applied is a conservative force, then the work done by displacing this body from A to B along this path will be same as that of if I am displacing this body by covering a path like this. Okay, so if the work done by the applied force is independent of the path followed, then that type of force is known as what? Conservative force. So by doing work with a conservative force, it does not depends upon the path followed by the body, it only depends upon the initial and final position. So here we can add another point, it only depends upon the initial and final position of the body. Okay, so the force by which work done is independent of the path followed is known as conservative force, and the work done only depends upon the initial and final position of the body. These type of forces are known as conservative force. One example of this type of force is gravitational force. Okay, electrostatic force can also be conservative force, gravitational force. These are the forces which depends only on the initial and final position of the body, does not depends upon the what path you are covering to displace the body from the initial point to final point. Clear? Next is non-conservative force. So what is non-conservative force? So these are the force work done by which depends on path followed. Okay, if work done by the force depends on the path followed by the body, for the same example, if the body is displaced from A to B, first by applying a force F, the body is displacing along this direction, and due to application of same force along this path, the body gets displaced. But the work done during these two displacements or during these two paths is different, then this applied force is known as non-conservative force. Clear? So these are the forces work done by which depends on the path followed are known as non-conservative force. Clear? Example, frictional force. Okay, so frictional force is an example of what? Non-conservative force. Again, you have to remember, in case of conservative force, work done in a closed path is 0. In case of conservative force, work done in a closed path is 0, but not in case of non-conservative force. Okay, so these are two types of forces, conservative force and non-conservative force. Okay, so in conservative force, the work done is independent of path followed, and in a closed path the work done is 0. But in case of non-conservative force, the work done depends upon the actual path followed by the body, and in a closed path the work done can't be 0. Okay, and the example of non-conservative forces, one is frictional force, and in conservative force it is gravitational and electromagnetic force. Clear? So if a force is given, so how to check a given force is conservative or non-conservative? So any constant force, is conservative. Example, if F is given as 3I cap, so this is a constant force. So this type of force are conservative forces. Okay, any constant force is conservative in nature. Or if the force is given as 3I cap minus 2J cap plus 6K cap, this is also a constant force. So these type of force which are constant by nature is conservative in nature. Or if the force is given as x I cap plus y j cap plus z k cap, then also if along I component there is only x component, along j component there is only y, and along k component there is only z, then also the force is conservative. So if a force is constant, or if a force is represented like this x I cap plus y j cap plus z k cap, then also it's conservative. In nature. Okay, but if F is given as x y I cap plus y z k cap plus zx j cap. That means the component of I, k and j are a combination of xy. Then how to check the force is conservative or not? So in this case you have to check del f of x by del y must be equal to del f of y by del x, and del f of z by del y must be equal to del f of y by del z, and del f of z by del x must be equal to del f of x by del z. If these three conditions are satisfied, then the force will be conservative, where f of y, f of x and f of z are what? The component of I cap, j cap and k cap. Clear? So this is how you can check whether a given force is conservative or not, and what is conservative force and what is non-conservative force. Clear? So this is all about today's lecture. In next class we will discuss further. Okay, thank you.